On our previous session, we have discussed about applications of Carnot cycle that are a heat engine, heat pump, and refrigerator. And we are going to see the problem on heat engine first. So, our question 1: a heat engine develops 10 kilowatt of power, then receiving a heat at the rate of 2250 kilojoule per minute. Evaluate the corresponding rate of heat rejection from the engine and its thermal efficiency. So first, while reading the question, we want to understand whether it is heat engine problem or heat pump problem or refrigerator. So in our question, they have clearly mentioned it is a heat engine. So when it is mentioned as heat engine, so draw the diagram of heat engine. So heat engine will have two reservoirs. One is called high temperature reservoir, is called source, and other reservoir is called sink, which is called as a low temperature reservoir. And center you want to draw a heat engine. The source is named as T1 and sink is named as T2. And the heat which is supplied from the source is called Q1. The heat which is rejected from the heat engine is called as Q2. The work produced by a heat engine is called W1. So we have written here all as in a rate of heat transfer, rate of work transfer, and rate of heat rejected. So I means all the given data in terms of energy with respect to time. A heat engine develops 10 kilowatt of power. Power is defined as work done per time. The work done with respect to time is called power. So what produced by a heat engine it is per second it produces 10 kilojoule of energy. That is called as 10 kilojoule per second is called as 10 kilowatt. So the work produced by the engine is 10 kilowatt. When receiving a heat at the rate of 2250 kilojoule per minute. So the heat engine receives the heat. That is, heat is supplied from the source and it is received by the heat engine. The heat supplied is equal to heat supplied is named as Q1, which is equal to 2250 kilojoule per minute. So conversion of minute to second. Joule per second is called watt. You have to convert it into watt. To convert the minute, 1 minute is equal to 60 seconds. So we can multiply 60 with minute, it will become as second. So joule per second is called as watt. You will be getting 37.5 into 10 power 3 watt. Again we can write this, we can convert this kilo is called as 10 power 3 and we can write in the form of watts or joule per second. Keep all the energy terms in form of joule per second, that is called watt, or keep it as joule. So now from this question we need to find efficiency. We need to find the thermal efficiency and amount of heat is rejected from the engine. So we already know the concept of heat engine. In case of heat engine, the heat which is supplied to the heat engine, and the heat is supplied to the heat engine, a part of heat is converted into work and part of heat is rejected to the sink. If total heat supplied is 2250 and work we are getting is 10 into 10 power 3, so then the remaining term is called as our heat rejection. So we can use a mathematical expression for work done from our previous concepts. So work done can be written as, written as heat supplied minus heat rejected. Here in the given data they have given rate of work done and rate of heat supplied and rate of heat rejected. So we can write W.1 is called rate of work done is equal to rate of heat supplied minus rate of heat rejected. So from this we know the value of work done is given, that is 10 kilowatt, and heat supplied is given as 2250 kilojoule per minute. We are converted into second. So substitute the second value here, kilojoule per second value. So remaining term, only one unknown is present, that is called heat rejected to the sink, or the heat rejected from the heat engine is not known. We will need to find the value of Q2 dot. So we can find the value of Q2 dot. So two variables are known, only one variable is unknown. We can find that unknown variable. So we will be getting a value of 27.5 into 10 power 3 watt. Next, efficiency of heat engine. To find the efficiency of heat engine, we know that work done by heat supplied. This term can be expanded as 1 minus heat rejected by heat supplied. It is in the form of rate. You write it in the form of rate Q2 dot by Q1 dot. So we know this value. When you substitute the given data, you will get the efficiency is equal to 26.66 percentage. So thank you.